chemistry, there are three main blocks will be there, and it has been divided into physical chemistry, inorganic chemistry as well as with the organic chemistry. There are four qualitative properties will be there. They are depression in freezing point, elevation in boiling point, relative lowering of vapor pressure and osmotic pressure. Primary alkyl halide always prefers to undergo SN2 mechanism, whereas a tertiary alkyl halide will prefers to undergo SN1 mechanism. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, today we are going to understand about the model question paper which has been released from the Pre-University Board. I hope you that this time they have made the examination easy by giving the 15 choose the correct answers as well as with the 5 mark fill in the blanks. So let us understand the blueprint of the model question paper which has been released from the board, and later on we will understand how the pattern of examinations will be conducted on this time for the pre-university board. Okay. So this is just a blueprint about how the question can be raised from the each unit, and this blueprint again it has been released from the pre-university board itself. So here you can see that as we already know that in chemistry there are three main blocks will be there, and it has been divided into physical chemistry, inorganic chemistry as well as with the organic chemistry. So in physical chemistry, you know, there is a set of 5 units, that is a unit 1 solid state, unit 2 solution, unit 3 electrochemistry, unit 4 chemical kinetics and a unit 5 surface chemistry. Okay. Let us understand how the question will be raised from all the 5 units in the physical chemistry. You can see that in the solid state, the number of marks that can be allotted for this unit is 8, and you can expect one 1 mark question, that is in a part A. Okay. Either it may be in the choose the correct answers, either it will be in the fill in the blanks also. Okay. Then there is a 1 2 mark question. We'll understand what is the 2 mark question again with the pattern of question as we discussed today. Okay. So there is a 1 2 mark question and there is a 1 5 mark question. Remember, this 5 mark question in chemistry, there will be a no direct 5 mark question, and remember it can be split into 3 plus 2 or 2 plus 2 plus 1. Okay, or it may be 2 plus 1 plus 1 plus 1 also. Okay, so hope you know that how the pattern will be raised. Then coming into the solution unit, you know, from this unit we can expect 8 mark. You can see that there is a 2 question in a part A. So you can see that here we have divided the part A into 2 blocks. So one is for the fill in the blanks and one is for the choose the correct answers. So in the choose the correct answers itself, from the solution unit we can expect the 2 question, okay, and 1 question in the fill in the blanks. And coming into the part D, there is a 1 5 mark question, directly we can expect it. Okay. Coming into the electrochemistry unit, from this unit we can expect the 8 mark. You can see that we can expect 1 question in the choose the correct answers, 1 question in the 2 mark, whereas 1 question in the 5 mark. In 5 mark always there will be a numerical from the physical chemistry. Coming into the chemical kinetics, we can expect the 9 marks from this unit, and from this unit, you know, we can expect 1 choose the correct answers, 1 fill in the blank, 1 2 mark question and directly with a 1 5 mark question. Coming into their surface chemistry, this is a smallest unit in the physical chemistry, and from this unit we can expect only 1 choose the correct answers and 1 5 mark question in the part D. Okay, and remember, when I say it is a physical chemistry, always there will be a numerical. So if you doesn't know how to solve with the numerical also, at least try to write the formula For that, at least you'll get a 1 mark. Okay, and try to substitute the values for the formula that you know in a better way and try to write the answers, and the problems will be mainly consider from the NCERT textbook. Okay, from the NCERT textbook only they are going to choose a question and they are going to give for the examination, not other than any question will be provided for you. Okay, then so the total number of marks that will be allotted only with the physical chemistry is 39. Okay, let's go with the inorganic chemistry now. Again, in inorganic chemistry, we have a set of 4 units. One is Unit 6, General Principle and the Process of Isolation of the Element. You know that this is a unit of metallurgy, where from this unit, you know, we can expect only 4 marks because it's the smallest unit. You can see that in organic chemistry, there will be a no 5 mark question directly. There is only 3 mark questions will be there in the part C. Hope you know that. In a part C is mainly meant for the inorganic chemistry only. Okay, inorganic chemistry units. Coming into the P block. So, this is the highest scoring unit, and most of them you will feel that it's one of the toughest units. Actually, it is not. If you know the periodic table and the trend in detail, it's very easy to learn with the P block elements. And from this unit, you can see that there is a 1 fill in the blanks, 1 choose the correct answers, and directly 3 mark question we can expect it in a part C. And you must know that how this 3 mark question will be split and it can be asked. Okay. Remember, in the 3 mark question, you know, they can ask with the manufacturing process of ammonia or with the nitric acid or with the sulfuric acid or any of the reactions, or with the formation of oxo acids, or with any kinds of reaction, what will be the product, like that, you know, the question can be raised, and it is one of the important unit for the inorganic chemistry too. Coming into the D and F block elements, from this unit, you know, we can expect only 1 choose the correct answers and 1 2 mark question and 2 3 mark question. You must know in this unit also there is a lot of important questions are there regarding to the lanthanide series or actinide series, or with the consequences, or with the differences, or with their catalytic behavior, why the D block elements are colored, you know, based upon the reason, or with the calculation with the magnetic moment, or why the substances is behaving like a reducing agent. Many questions can be raised, and you must know the pattern of how the question can be raised from this unit also. Coming into coordination compounds, we know that it is one of the easiest unit, because from this unit, you know, only 7 marks is allotted. 1 we can expect it in the choose the correct answers, and 2 3 mark question. In 3 mark question, definitely 1 3 mark question will be based upon writing the complexes. By knowing the atomic number, by knowing its oxidation state, and how the complexes will be formed also, we can write it. And other question will be based upon the degeneracy. Okay, that is splitting up of d orbital, how it can be split in octahedral complexes as well as with the tetrahedral complexes, it is mainly based upon. Coming into the organic chemistry, in organic chemistry 7 units are there. You can see that in a haloalkenes and haloarenes, there is 8 marks will be allotted. There is a 1 choose the correct answers, 1 2 mark question, and directly we can expect 1 5 mark. Meanwhile, we will move for the aldehyde, ketone and carboxylic acid. There is a 1 choose the correct answers, 1 2 mark question and 1 5 mark question. Remember, when they asked in the 2 mark question, it is all about the simplest preparation of an aldehyde or with a ketone or with a named reaction. Okay, you must know it properly. Then coming into that aldehyde, ketone and carboxylic acid, from this unit also it is 8 mark, 1 choose the correct answers, and also there is a 1 direct 5 mark question will be there. Coming into the amines unit, from this unit only 6 marks are allotted, 1 mark and 1 5 mark also. Coming into the biomolecules, remember in the biomolecules unit again the Hawa structure can be asked for any of the compounds. Okay, it may be for glucose or for fructose or for cellulose or starch. any of the compounds can be asked, and in that unit also you are going to learn about vitamins, proteins, enzymes, from any of the part they can raise a question. Coming into the polymer unit, from this unit only 5 marks are allotted, directly 1 5-mark question we can expect it. And chemistry in everyday life, that is the smallest unit in organic chemistry, from this unit also they can give a 5 mark, that will be 1 from the fill in the blanks, 2 from the 2 marks we can expect it. So totally 5 marks will be allotted for the chemistry in everyday life. So by studying only organic chemistry units you can expect 45 marks. Only by studying the inorganic chemistry you can guess there is a 31 marks will be there, and from the organic chemistry it is 45. Okay, totally the entire question paper will be set for 115 marks. Okay, so this is a blueprint about the second PUC chemistry question paper. Next we will see with the general guidelines for the model question paper or for the final exam too. Okay, the question should not be ambiguous and answers should be available in a prescribed textbook. Okay, so whatever the answers you will write in for the exam, it should be from the NCERT only. You should not write in your own words. Okay, no application type of question in a part A, and all the question will be a knowledge based and it is moderate. In part B, part C and part D, 40% of questions are knowledge based and 40% of the questions are moderate and 20% of the questions are skill based, and application type of question can be asked. Okay, and the question should be selected from the respective chapters of the particular question and numbers as per the blueprint. And in the part 1, as I told you, there is a set of 15 questions will be there, and it is all MCQ questions from the each unit from 1 to 14. Okay, from the chemistry in everyday life, they are not going to ask the choose the correct answers. Okay, those unit you must know which are the unit that we are not going to consider for the match the following. Then for the part B, that is in the fill in the blanks question, the units such as 1, 4, 7, 10 and 15 will be selected. Please write down this. These are the unit that they have chosen only to make the fill in the blanks. Okay, from those unit only we can expect the fill in the blanks. And in the P block element, unit 7, the question number 8 and 18 are suggested to take it from the noble gases. So hope you know that in the P block most of the questions will be raised from the noble gases only. You must know that. And for the parts B, C, D, previous year guidelines and before 2019 are applicable too. So this is a outlook about the board paper, that is the Department of Pre-University Education model question paper. You can see that how the marks are distributed here. In a part 1, okay, each question will carries 1 mark. Okay, there are 15 questions will be there, each will carry 1 mark. So 15 marks you can easily get it. And also there is a set of 5 questions which is in the form of fill in the blanks, and for that you will get a 5 mark, and totally in the part A only you are going to get easily 20 mark. In part B it carries the 8 marks and each question will carries about 2 marks. Okay, in part C these are the 3 mark question, you can easily get 12 marks, and in the part D these are 5 mark question. Part D is again divided into 4th main and 5th main, and 5th main is only for organic chemistry, and in 4th main we can expect physical chemistry questions. Okay, so part D will carry 30 marks, each question will carry about 5 marks, and write the balanced chemical equation and all the diagram wherever necessary, and use a log table and simple calculator if it is necessary for the calculation. Okay, these are the guidelines and marks distribution for each part. Hope you all understood. These are the set of questions which can be raised in the part A. You can see that there is a set of 15 questions are there. And you can see that there are set of 5 questions which carries 1 mark, and answer is also given. And as I said, these are the unit which will be specifically mentioned to take it up with the fill in the blanks from those unit only, they will take it up. And these are the part B question, okay. So any 4 you have to answer, any 4 which carries 2 marks, so you will get 8 mark easily. Then in the part C, as I said, any 4 again you have to attend, 3 mark will be there. So 4 3s are 12 marks, you can easily get it. Coming into the 5th main, as I said, that is in a part D. This is a 5th main. You can see that this is based upon the physical chemistry question. Afterwards, you can say that the 6th main, where you can see with the organic chemistry question. Okay. Now we will discuss one by one and how the question will be raised. Okay. Select the correct option from the given choices. First question, as I said, this question will be come from the solid state. That is the first unit in the physical chemistry. Due to Frankel defect, the density of the ionic solid is, as we all know that in a Frankel defect, when they say, okay, when they talk about the Frankel defect, remember the density of that entire solid but doesn't undergo any changes. Whereas in the Schottky defect, this is going to be decreases. Okay, don't confuse with the defect that has been given. Understand which defect is given and what will happen to the density. Okay, so density does not get changed, it remains as such. Okay, then in which mode of expression the concentration of the solution remain independent upon temperature? As we all know that it is independent only in the molality. Okay. Next, which of the following is not a colligative property? So this is a question from the solution unit. So as early we understood that there are 4 colligative properties will be there. They are depression in freezing point, elevation in boiling point, relative lowering of vapor pressure and osmotic pressure. You can see that we have a depression in freezing point, osmotic pressure and elevation in boiling point. 3 is given already. So the 4th one which you see, that is different. So this is will be a right answer, which is not a colligative property. So you can see that there are 2 questions which has been raised from the choose the correct answers from the unit known as solution. Okay. Next, during the electrolysis of molten sodium chloride, the reactions which occurs at anode. So we know that an anode oxidation should take place. Correct? So oxidation in the sense which gas has to be released? The negatively charged gas has to be released. Correct? So the chlorine get oxidized or chloride ion is get oxidized at anode. Next, the unit of rate constant for a zero order reaction. This is a question from the chemical kinetics, that is a unit 4. What is the unit for the zero order reaction? As we know that it is nothing but mole per liter per second. Okay. Next, in the process of adsorption, what will happen to the change in enthalpy and change in entropy? As we have already discussed that in the surface chemistry unit, adsorption is just a phenomena where the particles are going to be adsorbed on the particular substances. Correct? So it may be a solid or it may be a liquid or anything may be. Correct? So during that process of adsorption, what is the changes in entropy and enthalpy? We must know that along with the free energy change. So during the adsorption, both enthalpy and entropy is going to be changed and it has become negative if it is a spontaneous reaction. So I'll choose with the change in the enthalpy and entropy will be negative. It should not be a positive. If it is a positive, then the reaction should be a non-spontaneous. If it is spontaneous, should be get negative. Next, a pair of metal which has been purified from Van Arkel method. We know that from the Van Arkel method, we use the 2 metal to get purified. One is zirconium and titanium. Okay. Next, the noble gases which do not occur in the atmosphere. So you must know that, as I said, The question from the P block will be mainly asked from the noble gases only. Okay. Since it has been asked from the noble gases, you must know in detail about the noble gases. Correct? So, noble gases are the elements which is there in the periodic table 8, that is in the last group. Correct now? So, that element is nothing but radon, which do not occur in the atmosphere. Next, the elements which do not show variable oxidation state. What is mean by variable oxidation state? In addition to the common oxidation state, which are the other oxidation state which are exhibited by the element. So, as we know that vanadium, iron and mercury, correct? All these elements can show the variable oxidation state, whereas scandium, it has only one electron in the d orbital, correct? So, it does not show any variable oxidation state. Next, an example for ambidentate ligand. So, already we have learned that what is mean by ambidentate ligand. The ligand which can ligate it towards a central metal atom. Correct? So, those ligands are nothing but cyanide ligand. Next, primary alkyl halide prefers to undergo what type of reaction? So, this is a question from the haloalkanes and haloarine. So, we know that primary alkyl halide always prefers to undergo SN2 mechanism, whereas a tertiary alkyl halide will prefers to undergo SN1 mechanism. So, the answer is SN1 reaction. Next, when phenol is treated with excess of bromine, it gives rise to what? When phenol means what? A benzene with alcohol as their functional group. When it is treated with excess of bromine water, it is going to give 2, 4, 6. It gives 2, 4, 6 tribromophenol. Correct? So, you need to balance it. Okay? Answer is 2, 4, tribromophenol. Next, in a Clemmensen reduction, carbonyl compound is treated with dash to form a corresponding hydrocarbon. So, it has been treated with zinc amalgam with concentrated HCl. Amongst which of the following is a strong base in an aqueous medium? Strong base in the sense, so you can see that this is a primary amine, this is a secondary amine, this is a primary aryl amine. So, primary amines are least basic than the tertiary amine. We have to see which is the tertiary amine here. So, tertiary amine is your CH3 3 times N. This is a tertiary amine which is more basic compared with the primary alkyl amine or a primary aryl amine. Next, starch is a polymer of alpha D glucose or beta D glucose or alpha D fructose and beta D fructose. As we discussed with the biomolecules unit, we know that starch is a polymer of alpha D glucose. Next, we'll move on to the fill in the blanks now. So, it is very easy to identify the fill in the blanks answers. Answers are already given in the fill in the blanks itself. Just choose and write it. Okay. So, the first question will be goes like this. Dash in the nitrogen gas is an example for gaseous solution. We know that answers you can see that a camphor in nitrogen gas. Answer is camphor in nitrogen gas is an example for gaseous solution. In first order reaction, the concentration of reaction decreases exceptionally with time. Okay. Next, the first noble gases was first prepared by reacting the xenon with platinum hexafluoride, that is PTS6. Then the poisonous gas is dash formed when chloroform is exposed with the air and light. We know that this is a question from the P block and the poisonous gas is nothing but your phosgene. Correct? Okay. The main constituents of Dettol and chloroxenol is terpenol. So these are the very easiest question which has been raised from the units as I discussed with the blueprint. Okay. Next we'll go with a 2-mark question, that is in part B. Okay. So as I said, in a part B, okay, you need to attend only 4 questions. So here, each 4 question will carry 2 marks. So you can easily get the 8 marks from the part B only. Okay. So which are the question? As I said with the blueprint, there is a 2-mark question will be there from the solid state. So either they can ask the numericals here for the 2 mark. They can ask the differences between the crystalline solid or amorphous solid. They can ask with the Schottky defect or the Frankel defect, or they can ask with the differences between the N-type or P-type, or they can ask with the magnetic behavior. That means to say that they can ask what is ferromagnetic, given example, ferrimagnetic with the given example, diamagnetic, paramagnetic. So based upon the magnetic behavior also, we can expect the 2 mark, or based upon the defects, okay, they can ask here, or the differences between the amorphous and the crystalline solid too. Okay. So in the examination, if they ask you to write the differences, 2 proper differences you must write, not more than that. And you must carefully understand that what differences you are writing, is that same or not also. Make sure that then write. Give any 2 differences between crystalline and amorphous solid. So I have listed about the 5 differences in the examination. 2 is enough. Whichever the easiest differences you will find it, you can write it. Okay. So they are called as true solid. Amorphous solids are known as pseudo solids, and they have a definite geometric shape. They don't have a definite geometric shape. We call it as irregular shape, and they have a long range of order, they have a short range of order, and have a crystalline solids have a sharp melting point, whereas amorphous solid do not have a sharp melting point. It changes with the temperature, and they are anisotropic in nature, whereas amorphous solids are isotropic in nature. Coming into the next question, conductivity of 0.20 molarity of solution of KCl at 298 Kelvin is 0.0248 Simon per centimeter. Calculate the molar conductivity. Okay. So here we know that molar conductivity is given by a formula, that is molar conductivity is equal to 1000 into K divided by C. So what is K here? K is nothing but your conductivity, which is given 0.0248 Simon per centimeter. What is the concentration or molarity they have given? 0.20 m. So what do you need to calculate? You need to calculate about the molar conductivity. So apply this formula and substitute 1000 into 0.0248 divided by 0.20. Okay. So if you do this calculation, you will get it as 124 Simon centimeter square per mole. So this is the answer. When we do the substitution, you will get 124 Simon centimeter square per mole. If you have a doubt, substitute with the units they have given. Okay, Simon per centimeter. And when you are expressing the concentration, it should be centimeters mole. Correct? No? So centimeter cube it is. So 1 centimeter cube, 1 centimeter cube will get cancelled out, and you will get Simon centimeter square per mole. Okay. Next, define the molarity, and for a zero order reaction, what will be the molarity? So as we know that molarity is nothing but number of reacting species, correct? So number of reacting species, it may be an atom or ion or molecules taking part in the elementary reactions, that are said to be what? Molecularity. And remember, they are asking the molecularity of a zero order reaction. If I say it is a molecularity, we must consider the number of reacting species. In zero order, what will happen to the molecularity? Which remains 0 only, because in zero molecularity means there is no reactant. If there is no reactant, imagine how we can write the molecularity for the zero order reaction. There must be a reactant to react with each other to form a product. If there is no reactant for the zero order, then how can we write the molecularity? Okay. Next, what is lanthanide contraction? Mention any one of its consequences. You must write what is a lanthanide contraction. So, we know that lanthanide contraction is nothing but gradual decreasing in atomic size. Correct? Gradual decreasing in size of the lanthanide atoms and ions with increasing in atomic number is said to be a lanthanide contraction, and one of the consequences is there is a similarity in the properties of second and the third transition series. Okay. So, in the second as well as in the third transition series, we can find the similarity because of the lanthanide contraction. What is lanthanide contraction? Decreasing in atomic size. Next, what is the composition of Lucas reagent? What is the inference will be absorbed when a tertiary alcohol is treated with Lucas reagent? We know that Lucas reagent is nothing but a mixture of anhydrous zinc chloride with concentrated HCl, and this reagent that we used to test for distinguish between the primary, secondary and tertiary alcohol. So, when we treat the tertiary alcohol with the Lucas reagent, you will get an immediate turbidity, whereas with the secondary alcohol, you will get in turbidity after 5 minutes, whereas for the primary alcohol, you will get in turbidity after heating. Okay. So, this is a question from the alcohol. Next, explain Herold-Zelinsky reaction. So, the carboxylic acid, again the aldehyde ketone and a carboxylic part they have asked here. The carboxylic acid having a alpha hydrogen are halogenated at a alpha position on treatment with a chlorine or a bromine in presence of small amount of red phosphorus to give a alpha halocarboxylic acid, and these reactions are called as what? Herold-Zelinsky reaction. So, here I have written a general reaction. You can go with a specific example too. Okay. So, here I have written a carboxylic acid which are having alpha hydrogen. So, this is a carboxylic group, right? And this is a carbon which is attached to one more carbon atom, and these hydrogen are known as what? Alpha hydrogen. Correct? So, for this, if you attach any of the halogen, then it is said to be what? Herold-Zelinsky reaction. So, this will be taken place in presence of red phosphorus, and you are going to add an halogen. So, what will be the product? One of the hydrogen you are going to remove it and you are going to substitute with an halogen. You will get an alpha halocarboxylic acid. You can go with any of the specific example. Next, what are fruit preservative? Give an example. As we all know that there is a two-mark question from the chemistry in everyday life, and these two questions can be raised from the medicinal field, or they can ask any question from the preservatives or with the soaps and detergents too. Okay, be careful with that unit. So, any substances if we add to the food substances in order to preserve it for the longer time, those substances are called as what? Food preservatives. Okay, example, we are familiar with the salt and sugar that we still added today to preserve the food. In addition to it, sodium benzoate is a chemical substances that we add for the food to keep it for the longer time. Okay, why we have to keep it for longer time? In order to avoid for the spoilage of food or to any of the attack of microbials, we need to avoid it. That is why we add the certain substances. Okay, those substances are called as what? Food preservatives. Explain the saponification with an example. So, this is a soap preparation, hope you know that, where natural soaps are nothing but sodium or the potassium salts of carboxylic acid, and we know that when alkali hydrolysis, when we do for the esters of fatty acids, okay, here I have taken the glycerol esters of fatty acids which has been treated with an strong base, that is sodium hydroxide. You will get an sodium stearate as well as the glycerol. Okay. So, this sodium stearate is your soap. Okay. So, this process of preparation of soap by a process called as saponification, by treating fatty acids with a strong base, it is said to be what? Saponification. We will move for the part C now. In part C, let us see how the question will be raised from the inorganic chemistry. You need to answer only 4 questions in this part C. Each question will carry how many marks? 3 marks. Okay. Write the reaction which are involved in process of leaching of bauxite ore to prepare pure alumina. We know that pure alumina is prepared by using bauxite ore. Okay. So here the bauxite ore in the first step, which has been treated with the base in presence of an water, you will get an sodium aluminate. Okay. Along with this, you will also get an silicon dioxide as a impurities. This sodium aluminate in the next step, if you treat it with a carbon dioxide gas, you will get an aluminium oxide and sodium bicarbonate is also obtained. But in this step, the seeding will be done. Okay. Seeding in the sense what? Seeding in the sense they'll add the freshly prepared aluminium oxide for the aluminium oxide only in order to increase the precipitation. Okay. So that process is called as seeding. So in the last step, the hydrated aluminum oxide will be taken and it will be heated with very high temperature. You will get an aluminum oxide with the elimination of water. Okay. These are the 3 steps. You must write it and it must be balanced. And if you know the way to write in your own words, you can write with the explanation part. But the reaction you have to write it in a neat manner and it should be balanced to both the sides. Next, write the optimum condition to get an ammonia by Haber's process. We all know that ammonia is prepared mainly from the Haber's process. What are the optimum condition that we use for this process? You must know. So, which are the optimum condition? We use the temperature, we use the pressure and also we use a specific catalyst too. So, the optimum temperatures are 700 Kelvin and optimum pressure is around 200 atm and the catalyst will be used as iron oxide. Okay. Next, give an example for each basic oxide and a neutral oxide and what happens when sulfur dioxide gas is passed over the aqueous solution of iron 3 salt. So, here what has happened with the sulfur dioxide gas which we pass through the iron 3 oxide, and you must recognize one as a basic oxide, one neutral oxide. We are familiar with the neutral oxide by studying with the nitrogen family, that is a nitric oxide, correct? NO. Whereas in the basic oxide, you can take with the calcium oxide or with the barium oxide or with the sodium oxide. They are the basic oxide. Coming into the second question, okay, these 2 questions will carry 2 marks and these last question will carry for 1 mark. Okay. When sulfur dioxide gas is passed over the iron 3 aqueous solution, okay, sulfur dioxide gas if you passed over, iron from the +3 oxidation state get reduced to +2 oxidation state. That is, ferric ion is converted into ferrous ion. So, this is a use of passing the sulfur dioxide gas to the aqueous solution of iron 3 oxide. Next, explain the bleaching action of chlorine water. So, we know that still we prepare the chlorine water from the bleaching powder and it has a bleaching action too, correct? So, chlorine water on standing loses its yellow color due to the formation of HCl and HOCl, and HOCl is nothing but hypochlorous acid, is unstable and decomposes to give a nascent oxygen which is responsible for oxidizing and bleaching action of the chlorine. Most of the chlorine also behaves like a oxidizing and bleaching agent. So, here you need to understand how the bleaching action of the chlorine will be expressed. Okay. When chlorine is dissolved in water, it releases what? HCl gas and HOCl, that is hypochlorous acid. Hypochlorous acid in turn it can give rise to the HCl and nascent oxygen. Coming into the halogen which can forms only one type of oxo acids. We all know that in the group 17, okay, that is a halogen family. Fluorine is only the element, it can form only one type of oxo acids and that oxo acids is hypofluorous acids. Okay. Next, calculate the spin-only magnetic moment of M plus 3 ion and their atomic number is given. And the second question is scandium is colorless in plus 3 oxidation state. Give an example. I'll go with the first question now. Okay. So we have to calculate what? Magnetic moment. How do you calculate the magnetic moment? With the formula mu is equal to square root of n into n plus 2 Bohr magneton. Correct. So what is n here? N is nothing but what? Number of unpaired electron. Unpaired electron. So now how do you find out the number of electron? By giving with the example, they have given Z is equal to 27 and we must know that 27 is nothing but your cobalt. Correct? Atomic number 27 is nothing but your cobalt. And how do you write the electronic configuration? Argon 3d7 4s2. 3d7 4s2. So here they are telling that metal ion in a plus 3 oxidation state. Plus 3 in the sense it loses 3 electron. So you will write argon 3d6 4s0. Correct. 3d6 how do you write it? So write the d orbital 3, 4, 5. So how many electrons we have? 1, 2, 3, 4, 5, 6. So you can see that there is a 4 unpaired electrons are there, correct? In the plus 3 oxidation state. Now you substitute. Square root of 4 into 4 plus 2. How much you will get it? 4 into 6. 24. We will get approximately 4.8. Correct? So this is how you will calculate the spin-only magnetic moment by using the formula and by knowing the atomic number and how many number of unpaired electrons are there in its oxidation state. It may be in the plus 3, plus 2 or whatever it is given. Okay. Try to understand this. Then coming into the second question, scandium in a plus 3 oxidation state is colorless. What is the reason? We know that the scandium in the plus 3 oxidation state, it has a 0 electron in the 3d orbital as well as 0 electron in the 4s, correct? So its electronic configuration, scandium in plus 3, it is argon 3d0 4s0. Since it has a 0 electrons or no electron in d orbital, there is no dd transition will take place. We know that the electrons which is there as unpaired will be responsible for giving a color to the complexes. Correct? Scandium in plus 3 oxidation state, it do not contains any electrons or any unpaired electrons. Okay, hence it will become colorless. Next, how pure potassium dichromate is manufactured by chromate ore. Okay, so again for the preparation of potassium dichromate, 3 steps that should be balanced. With your own explanation, it's enough. You must write it in a 3 step. Okay, the first step is we are taking the chromite ore which has been treated with the sodium carbonate in presence of an air which are containing an oxygen. You will get sodium chromate. In the next step, you know, the sodium chromate which has been treated with H2SO4, okay, freshly prepared or it should be get acidified. They'll treat it and you'll get it what? Sodium dichromate you will get. But our intention is to prepare with what? Potassium dichromate. In third step, sodium dichromate is treated with KCl to get potassium dichromate and sodium chloride. These are the 3 steps. With the balancing, you must write it down. Next question, on the basis of valence bond theory, explain the hybridization in structure and magnetic property of a complex nickel with the 4 chlorine atom in a -2, that is tetrachlorido-nickelate ion or nickel tetrachloride. We know that nickel will be exhibits in a +2 oxidation state. How do you say that, ma'am? So find out NiCl4 -2. Great. So we don't know about the nickel. Take it as X plus 4 into each halogen will donate a -1 as their plus oxidation state is equal to minus 2, x minus 4 is equal to minus 2, x is equal to minus 2 plus 4, x is equal to plus 2. Okay, so this is the oxidation state of the nickel in the nickel tetrachloride. And electronic configuration, so we must know that nickel electronic configuration in a plus 2, correct. This is the general electronic configuration of nickel, that is argon 3d8 4s2. What they are telling, we have to write the electronic configuration in plus 2. So here I can write the plus 2 electronic configuration by removing the 2 electron in the 4s orbital. You will get 3d8 and 4s 0, correct. 3d8 and 4s 0, and you must know that nickel, which is attacked by 4 chlorido ligand. The chlorines or halogens are weak field ligand, correct? No. So no pairing of unpaired electron will take it up. So we must have a 4 vacant places, correct? No. Already we have a 2 unpaired electron. Other 4 vacant places we wanted, that is given by 4s and 4p, and these 4 will get attacked by the 4 chlorido ligand and get filled with the 4s and 4p, and you can say that 4 pairs of electrons will form a 1 each chlorine ion and occupy to form a sp3 hybrid orbital, and it gives what? Tetrahedral shape. Okay, and you can see that there is a 2 unpaired electrons will be there in the orbital, hence they are paramagnetic in nature. Okay. You must know the geometry, magnetic behavior, and how to write it with the different oxidation state. If it is a strong ligand, if it is a weak ligand, what will be the approach? You must know that, and what is a hybridization. Next question, draw the energy level diagram to show that splitting of degenerated orbital in an octahedral crystal splitting. And next question is, write the type of isomers which are exhibited by coordinate complexes which are having ambidentate ligand. First, I'll go with the splitting of octahedral complexes. So first, we must know that this is a free metal ion which are having the 5 degenerated d orbital. Degeneracy or degenerated means same energy level. Okay. So these are the 5 degenerated orbitals of the d block. When it is approached, okay, when it is approached, okay, imagine this is your metal ion which is get approached by 6 ligand. When it is get approached by 6 ligand, it will form a octahedral complexes. No, so the degenerated orbital will split to give a 2 different energy level. One is known as T2G and the one is known as EGZ. In T2G, you know, always dxy, dyz and dzx will be there. Whereas in the EG level, always dx square minus y square and dz square will be there. Okay. So here you can see that the energy differences between these two energy levels are 3 by 5 delta O and this is minus 2 by 5 delta O, and line which makes the differences between these two energy levels are known as what? Barycenter. Okay. Same energy level diagram you have to write it for tetrahedral complex 2, and where the splitting up of d orbital will be different, energy level will be different. Next question, that is you have to know the linkage isomers. Linkage isomers is a type of isomers in which 2 compounds are differs in the donor atom of the ligand, and this donor atoms are nothing but ambidentate ligand. And you can see that here the 2 sets of example I have written, 5 amino ligand as well as with the NO2 nitrato ligand which we have, and here this nitrato ligand are of 2 types. It can be ligated to the oxygen atom or with a nitrogen atom. Those ligands are known as what? Ambidentate ligand. One more example is 5 amino with HCN. So HCN, it can directly ligate with a sulfur atom, either it can ligate it with a nitrogen atom. Hence it is an example for ambidentate ligand. So this is how, you know, the second question, linkage isomers with the ambidentate ligand, you must write it down. Okay, these are all with the 3-mark question in a part C. Hope you all understood. I'll come back with the session 2 with the part D from the physical as well as from the organic chemistry. We'll discuss it in the next session. Till that, take care and be safe and try to prepare for the exam. All the best. Thank you.